In a Formula One car, the brake pedal is not a command. It is a question. The front brakes obey it. The rear brakes only get asked. Behind the pedal sit two separate master cylinders, one for each axle. The front circuit is old school. Fluid pressure goes to the calipers, and the pads clamp the disc. At the rear, a sensor reads how hard the driver is pushing and treats it as a request. A control unit then fills that request from three places. First, the pads and the disc, carbon squeezed by a caliper, turning speed into heat, running hot enough to glow. Second, engine braking. Lift off the throttle, and the engine itself drags on the rear wheels. Third, the MGU-K. Under power, it pushes the car. Under braking, it flips into a generator, and turning that generator takes effort. That effort comes from the rear wheels. Engineers call it harvesting. It slows the car and fills the battery at the same time. Here is the problem the computer solves. How much the hybrid harvests changes constantly, with speed, with battery charge, and with how much energy the team wants banked for the next straight. So brake-by-wire trims the hydraulic pressure at the rear pads, moment by moment, so the total always matches what the driver asked for. It also moves the brake balance during the corner. On the way in, the car takes rear brake away so the back end does not step out. As the driver eases toward the apex, it feeds rear brake back in. Engineers call that brake migration. The rules build in a floor. Under the 2026 regulations, the rear brakes must still make 2,500 Newton meters of torque per wheel at 150 bar of pedal pressure, with no help at all from the power unit. And 2026 is why this matters now. The MGU-K jumped from 120 kilowatts to as much as 350. Energy recovery went from 2 megajoules a lap to 8.5. If the generator is doing that much of the slowing, the rear pads are doing far less. Brembo redesigned the hardware around exactly that. Rear discs now run 260 to 280 millimeters. Maximum disc thickness went from 32 to 34, and calipers may use 3 mounting points instead of 2. Brembo called it the biggest caliper change in 20 years, and said rear systems could end up 20% smaller. Here's the catch. Carbon brakes need about 200 degrees Celsius before they bite properly. Take friction braking away, and the rear discs never get warm, and cold carbon does not grip consistently. At Monaco on June 7th, Charles Leclerc crashed out at Anthony Nogi's and said 3 of his 4 brakes were not working, with no deceleration showing at the rear at all. He switched brake disc supplier for the next race in Barcelona. Watch the braking zones and you will see the fingerprints. Rear ends snapping loose on entry, front tires locking and puffing smoke, and drivers grabbing first gear where third used to be plenty. So when a driver says the brakes went away now, he usually does not mean they overheated, he means they went cold. The pedal asks, the hybrid answers, follow happy hour racing for the tech behind the race.